To start, I'd like to acknowledge this country, the Yagara and Turrbal people, the land of which we meet, and pay our respects to their ancestors and descendants who continue cultural and spiritual connections to country. So today we are very lucky to have Professor Ben Halpern here today from California. So he is the director of NCES, which is the National Ecological Analysis Center for Ecological Analysis and Synthesis, which is arguably one of the world's premier ecological research institutions. Many people, raise your hand if you've been through NCES at all at one point in your life, in your career. That's right. Lots of people have done postdocs there. They're famous for holding workshops on really critical problems. It's an absolutely fantastic place to be. And Ben is holding down the fort at NCES, and he's been there for a long time. He's also at the Bren School of Environmental Science and Management, which is where I did my master's, as well as Kate as well. And that's at the University of California, Santa Barbara, another fantastic place to visit, obviously, since I went there and Kate went there. So Ben, just a little story. I guess Ben has a history of being coming to Australia. He really loves Australia. And I met Ben at the Bren School when I was a master's student, and he was a postdoc, I think at the time, or just after that. He was a young scientist who already had really established himself as a scientist back then. He was quite famous then for a very seminal paper showing that marine reserves actually do work, that if you stop fishing, indeed, the fish will be better off and the populations will grow and all of that amazing stuff. And it seems really obvious now, what, 20 some years later, but that was a big paper. And before I met Ben, Ben was my reviewer for my thesis as a master's student, which is, the thesis there is a big deal. It's like just a master's, but it was like big. And I had never met Ben. And then he came to the meeting to review my thesis, and he said, "Hi, I'm Ben." And I'm like, "Ben who?" Because I'm expecting this like super old man to walk in, and he was this young guy, because I thought he'd already, done a lot in the field, which is super cool. Since then, he has established himself quite well in a lot of different areas. He's done heaps of stuff on cumulative human impact mapping, ocean health index, and moving into food systems and all of that, which he will no doubt talk a lot about that, which is super, super cool and useful for conservation. We've had multiple grants together, 2 ARC grants, which means that we've gotten a reputation for having workshops in really amazing places like Heron Island and Fiji. And we're having a workshop on Monday here at the amazing St. Lucia campus. Things are really going downhill for us, Ben. We don't currently have any projects at the moment, so we're less funded. Come in. You can just come over here. Anyway, so can you welcome me in joining Ben to give a seminar, and then afterwards join us for pizza in the courtyard? That would be fantastic. And if you want to come to the workshop on Monday, everyone's welcome. Just talk to Erin over there. Ben, thank you.
All set? All right. Thank you all so much for coming. I know this is a quiet week here, so I appreciate your effort for coming out when you're heading into your winter holidays. And thank you, Carissa, for the opportunity to join you here and for that introduction, very kind. There's many other stories we can tell later about the long friendship and professional relationship we've had. Today, I'm going to do a bit of a different kind of talk. There are some research results in here, but I really want to kind of share my journey in thinking about how we are moving into the ocean for what people call the blue economy, and what that offers in terms of, I think, both opportunity and promise for really transformative solutions for our planet, but also some risks and challenges we face as we move into that. So I hope you come away maybe thinking differently about the ocean, or at least adding some new ideas into the way you think about the ocean. This is one of my favorite views of our planet. It's one that really hammers home that we are an ocean planet more than an Earth planet. It's the view where you really see very little land and the giant Pacific Ocean that dominates the side of our planet. And a lot of people look at the ocean as a resource, as a place that we can go to extract value and provide, use and economy to our human societies. A lot of us, on the other hand, think of it as a place we need to protect and set aside. And so these dual ideas of what the ocean represents for humanity and our society is something that has really motivated my thinking about what I want to do, not only as a scientist, but as a citizen, and as I think about the global push into the oceans under the blue economy. And that's really motivating what I want to talk about today. Setting the context, and as Carissa mentioned, a lot of my work in the last 20 years is focused on the ways that we have negatively impacted the ocean. So I want to take you back 20 years ago to where I first started thinking about the global ocean and the way that we affect it, and where we started to think about the cumulative effect that all these different uses have on the ocean. So it's not new that we are in the ocean, taking resources from it and benefiting from it. We've been doing this for centuries, if not millennia. But in the last century in particular, there's been a lot of push into the oceans and ways that we use it that are starting to put a lot of, or have already put a lot of strain on biodiversity and the ecosystems in there and the ability for the ocean to deliver value to people. So 20 years ago, I guess maybe a little less, we published this paper that was the cumulative human impact on the oceans, where we looked at mapping these different uses and their impact on habitats and biodiversity within the ocean. So we were able to leverage a lot of publicly available data on fishing and climate change and land-based pollution and coastal development and oil and gas development and so on, global shipping. And we could layer those on. So you have, in this case, coastal benthic fishing, and you can add in pelagic fishing, and then you can add in global shipping and transportation to produce this map, which maybe some of you have seen, which was the kind of the first view of this global cumulative human impact on the oceans. And when we published this at the time, and as we were developing these results, it was really quite surprising to us, and I think to many people in the world, this view of the ocean. Because you look at that ocean, that original view of our planet, where you see this truly vast ocean, and it's hard to imagine that we as humans could really have an impact across all of that space. But indeed, as we see here, well, it's not, you can't see it, but there's really no place that's untouched in the ocean. This is 20 years ago, the results from that. So there's nothing really left that you can count as pristine. And we found that 41% of it was heavily impacted. So these are the orange and red areas. So this is nearly half of the ocean had already suffered pretty substantial degradation at the hands of human activities. And in contrast, there's very little of it, mostly in the polar regions that are under sea ice much of the year, that are relatively untouched or lightly impacted. And so it's really less than 4% of the ocean, which is really not that much. So this is the background that I came into more recently, kind of thinking about, well, what does the blue economy mean for the ocean? We've already been having a pretty big impact on the ocean. And now in the last 5 or 10 years, and certainly looking forward, there's this push into the oceans, this kind of, it's really accelerating, seeing it as a last frontier, an opportunity. We've done a lot on land, and now there's a lot more space in the ocean. What can we do with this space? So there's kind of a rush into the ocean to harvest value and new uses out of it. So I'm going to focus on 3 in this presentation that are not the only ones, but I think are 3 of the big ones that are not only uses, but have the potential for serving as really transformative solutions to our sustainability problems. So I think there are 2 sides to these issues. One, which I'll talk about, are kind of the risks of what they mean for the oceans, but also the other side, the promise they hold for really addressing ways of providing resources that can sustainably feed our people and our economies in ways that could actually potentially save our planet. And so it's this dual tension, and I want to focus on these three to kind of narrate these stories as I'm thinking about it, and I think others are thinking about what the oceans mean, what the blue economy means for our future. So I'll tell the story through these three lenses, these three chapters, and then I'll return to the end to kind of share my thoughts on where we're headed. So I'm going to start with food. I've done a lot of work in the last 15 or 20 years on food, fisheries, as well as aquaculture, and learned a lot through that I think sets the stage for where we're heading in the future. So some of this, or much of it, you may already know, but in the last 100 years, we've seen a huge expansion of global fisheries through the commercial fisheries, but also in the last 40 or 50 years, the explosion of aquaculture. And in the last couple of years, since I think 2022, we now see half of all seafood to people coming from aquaculture. So we've now in a new era where the oceans and freshwater, but are serving food on our plates as much by farmed seafood as wild-caught seafood, which is really a state transition in the way that we've interacted with the oceans. On land, this happened centuries ago or millennia ago, where we shifted from hunter-gatherers to farmers, and now we've seen this shift happening in the oceans. When I first started my career getting into conservation of the oceans, this is kind of the view of the ocean, of aquaculture, that I was taught, and was really kind of the context. In the 80s and 90s, as aquaculture was initially exploding around the world, this is what a lot of the practices were. We had shrimp ponds, mowing down mangroves. In the last 30 or 40 years, we've lost about 30% of all the world's mangroves to shrimp ponds. And the salmon farms that were starting to form in Norway and British Columbia and Chile and the fjords were polluting the waters, creating dead zones in these areas. So this was the narrative and the reality of aquaculture when I was first starting my career. And so as a marine conservationist, I was like, the worst thing you can do in the oceans is farm seafood, because it's just destroying these really special places. I also grew up in Oregon, which is the Pacific Northwest of the United States. And if you're familiar with this part of the world, and British Columbia and Alaska as well, salmon is just profoundly important to the culture and the community, certainly the indigenous First Nation people of that region, but also the people who have come afterwards. Salmon is everything. And so the idea that you would risk this wild resource of salmon with fish farming was just an anathema. So these are the two kind of threads of my thinking and my training and my background in aquaculture that I stepped into starting to do research in aquaculture about 10 years ago, looking at whether or not it might be something that could be done in a sustainable way and provide a healthy, nutritious seafood source of food to people. And so I did a lot of research on this, initially on kind of fisheries and aquaculture, understanding the differences and the sustainability of the two, but quickly realized that the world of food sustainability science was highly segregated into land-based food and to ocean-based food, seafood. And the two had rarely been compared to understand how seafood compares to other foods. So you'd see like aquaculture is better than fisheries, or fisheries is better than aquaculture, and a lot of debate going on there, and how different terrestrial crops or livestock compared. But they hadn't been brought together. And I was really curious to understand how aquaculture in particular fit into this broader context of all food sustainability, to understand whether or not it really could be one of the solutions to sustainably feeding people while not over using our planet. And so this led to something we've been doing now for the last 8 or 10 years, doing these kinds of comparisons. And you may have seen some of this, but we took the same kind of cumulative pressure approach to thinking about food, to think about all the different types of key pressures that come from food production. So you've got climate emissions, nutrient pollution, freshwater use, and the actual disturbance of the land or the ocean that can displace native biodiversity. So these 4 key pressures are the main ones that are associated with food production. And we wanted to look at all four types of food production. So crops, terrestrial livestock, aquaculture, and fisheries. So those are the four dominant ways that we get food from our planet. And so if you look at the four different types of pressure, so greenhouse gas emissions, disturbance, nitrogen and phosphorus pollution, and water, you can see that different types of food production have different types of pressures associated with them. So fisheries, they're a wild stock, so there's no pollution from them. You're not fertilizing them, and there's no water use. So they're only connected to greenhouse gas emissions and disturbance, whereas livestock, they have all four associated with them. And there's different parts of the food production system and the waste from those that deliver different amounts and types of these pressures. So we bring that all together to sum up into a cumulative pressure metric for each of these food types to be able to compare them like for like. In this work, we also mapped it. I'm not going to show you that, but there was a lot of work to understand where the pressures are coming from, these different food production systems. But I want to just show you the way that they rank in terms of their efficiency. So how much environmental pressure is associated with any kilogram or pound of food production across these different systems. So you may be familiar with the fact that livestock is, one of the not so good ways of producing food in terms of its environmental footprint. So longer bars are less efficient. Those are the ones that have a greater cumulative environmental footprint for any kilogram or pound of food. So goat and sheep meat are actually the worst, but they're not a huge volume production globally. Cattle, you must have heard of at this point, is definitely the worst offender in terms of both its inefficiency and then, of course, the volume is huge. These rankings don't account for the volume. But you can see it goes pig, milk, eggs, and then chicken. And chicken's actually quite efficient in its production. You may disagree with the production system in terms of animal welfare. That's a different issue, but it's very, very efficient in terms of its environmental footprint. The volume of chicken production is just profound. It's 60 billion chicken a year are produced worldwide in a very, very efficient production system. So how does that compare to seafood? Fisheries, maybe not surprising, benthic fisheries that are dragging those huge nets, very heavy nets at deep waters, lots and lots of fuel to do that. Of course, the huge disturbance on the seafloor. Those are the worst of the fisheries. You get better and better as you move to smaller fish and pelagic fisheries systems. And in mariculture, which is farming the ocean, shrimp are the worst. They destroy the coastal habitat. There's a lot of pollution and emissions that come from that. Crustaceans are better. And then you get into the really good ones. Bivalves, tuna, fish in general. And then surprising to many people is salmon. Salmon has become super efficient in its farming, in part because it is so valuable. The companies have invested a lot into making it really efficient, and the pressure on the salmon farming industry has pushed them to fix a lot of the problems that existed in the past. And so salmon actually performs better than chicken in terms of its environmental efficiency. We looked at this against all the crops too. So I put the mariculture up there again for comparison, but most crops are actually less efficient than salmon, and many mariculture systems are better than many of the crops. So this really goes against the narrative that a vegetarian diet is the best for the planet. Certainly it's better in a lot of ways, but a lot of those comparisons about vegetarian versus meat focus primarily on just one of the pressures, usually climate emissions. Sometimes I look at the pollution, nitrogen, phosphorus pollution. But when you look at these environmental pressures in a cumulative way, it really changes the rank order and the understanding of the relative consequences of different food production systems. We only had a few of the mariculture categories that we could do for this global assessment across all food. But with Jessica Gephardt and a bunch of others, we looked at a larger set of aquaculture systems as well as wild-caught fisheries. We've added chicken here as that brown bar. So remember, chicken is your kind of best possible livestock. It's actually better than a lot of crops as well. But here you can look at the wild-caught fisheries and then on the top, farmed seafood against their carbon emissions. So this is looking at each of these environmental pressures one by one. And you can see that in most cases, the farmed seafood does better than chicken on carbon emissions. If you look at the other pressures, nitrogen pollution, phosphorus pollution, water use, and under here is area use, the amount of the footprint, the spatial footprint. Again, you see that these different categories of farmed seafood do quite well. They do better in most cases than chicken, which again is your best case scenario for livestock. So this really started to change my perspective on aquaculture. I would say profoundly changed my perspective on aquaculture. And I've gone from someone, as I said, who is very much against it because of the narrative and the evidence I was kind of raised in, to this new view that is the modern science of aquaculture and food systems that really is quite different, and showing that aquaculture is one of the most sustainable ways to produce food on the planet. Just to kind of hammer home a little bit more of this story, like this is the spatial footprint of wild-caught fisheries, commercial fishing that Global Fishing Watch has done by tracking from satellites where all those fishing boats are. You know, it's a huge part of the ocean, whether it's 5% or 50%, depending on exactly how you measure it, it's a lot of the ocean. And from all of that fishing, we get about 100 million metric tons of seafood. It's been quite stable for the last 20 or 30 years. It's actually slowly declining how much fish we get out of the global ocean, but roughly 100 million metric tons. We can produce, theoretically, that same amount of seafood from fish farming in the area the size of Lake Michigan in the United States, or roughly the size of Tasmania. So because you can produce it in a much, much smaller area and much more efficiently, not that we would do that, we're not advocating turning Lake Michigan into a giant farm, but that's just the potential for what you can do in terms of the space it takes to produce the same amount of seafood. So you can start to understand why or how fish farming can be a much more sustainable way of producing the food we eat. So like I said, I've really, I think, transformed my thinking on that. And with that thinking, I was like, well, I know it's not always done well. I'm not delusional about what fish farming is around the world. And last month, I went to China for the first time in order to start to see what it looks like when it's done at scale. Because if we're really going to move into the ocean in a huge way to produce food, it's going to be at a much larger scale even than we're doing today. And so I went to the Fujian province, which is across the straits from Taiwan. It's a big seafood area. And this is one of the larger areas for fish farming that is done. And I went to Dongsheng Bay, which is just south of the city of Xiamen. And this is what it looks like from the satellite. So this bay, it's huge. I don't know what the equivalent, I mean, it's much bigger than Sydney Harbor. I mean, it's a really huge bay. And it is half full of these farms. So this is what it looks like from the satellite. From just above the air, this is what it looks like. So this is all fish farms and abalone farms. Everything here has to be fed. And we went out on the boat, and like, it's just mind-boggling if you haven't seen this before, the scale at which this is. Like, there's basically floating cities. Every farm has a house on it for storing the feed and the restroom for the people who are working out there. They're all hand-fed, hand-managed. They have teams of workers who are every square farm. They're out there every day feeding, and it just goes on and on and on forever. And so, like, I know that this is one version of what the future could look like, and this is definitely not what I would want my ocean to look like. Certain cultures and places may be fine with that, and I guess that's maybe what the world will look like. But I don't know that I'm totally comfortable with that being the solution for what our ocean looks like. So, you know, I have become a huge proponent of the potential for aquaculture, but I also harbor some fear that if we are not careful about how we move into the ocean to produce food, this is what the future could look like. I'll return to this and what I think we should be doing, but that's the end of chapter 1, the story of what I think food in the ocean could look like and the potential for food production in the ocean to really be transformative to our planet and to people. So I want to move now into the second chapter, which is on energy. So as you probably know, there's a lot of interest in moving into the ocean for sustainable energy production, in particular through wind energy. There's a lot of untapped resource there, and it's a renewable resource that has the potential to really address all of our current and future energy needs. We're not there yet. This is where we're at currently with with energy production and consumption around the world. We use and produce about 180,000 terawatt hours of energy, and only about, I guess, a sixth of that is from renewable energy resources, and a tiny fraction of those renewable energy resources are coming from the ocean. So currently, not much is happening in the ocean. We're still predominantly a fossil fuel energy economy. But as we all know, we're trying to move into renewable resources because if we don't, there's a lot of other problems that are going to be happening from that. The oceans have a lot of potential for this. These are 4 key types of energy production potential in the oceans that are almost entirely untapped at the moment. So wave energy, there's waves everywhere. They have a lot of different types of systems that can be used to harvest that wave energy. These snaky ones that move around, or you have buoys that go up and down. They all drive turbines, just like you see in a hydroelectric dam, that produce the energy. And so there's an estimated 30,000 terawatt hours, so roughly doubling what our current renewable energy production is globally just from wave energy. There's tidal energy systems, which are much more limited in terms of their potential, but they're relatively easy to produce. Where we've got large tidal ranges, you can build these dams, essentially, that trap the tide when it comes in, and then as it releases, they drive the turbines, identical to a hydroelectric dam, except the water is flowing horizontally rather than vertically. They also have underwater tidal turbines that look more like the current ones, that as the tides move in and out, they spin and they'll turn around to adjust incoming versus outgoing tides. Current systems, so you got these large currents that go along continental shelves. Most places have them. They estimate about just under 4,000 terawatt hours, so not a huge energy resource, but a really easy one to install in these really large currents that are around the world. And then relatively small, it's just 10 to 15 terawatt hours, is ocean thermal energy conversion. So this you can do in tropical and subtropical areas where they pump up cold water from the deep and use the warm water from the surface, and then the warm water boils ammonia, which boils just above room temperature, to drive the turbines, and then the cool water recondenses it, and it's fully sustainable in that way. And so it's a really great system, in particular for tropical island nations, because they can install it locally and leverage their local resources for that. So these are almost entirely in pilot phases around the world, but there's huge potential to build them out if we chose to. Quite a lot of renewable energy from the ocean. But the big one is wind energy, and it is big. Like, until I started looking in this, I didn't realize how big it is and why there's so much interest in it, but it's the potential of 620,000 terawatt hours, so 4 times our current total global energy production and consumption could be done just from offshore wind energy. So it's just a massive resource, and that's why there's so much interest. It's also the furthest along. It's the one that has had the most production in the ocean already. It's pretty concentrated in maybe 13 or 14 countries. The UK and European Union countries have done a lot. China is really growing fast. And I guess Germany. So it's really UK, Germany, and China are the 3 major drivers so far. But these systems are getting bigger and bigger and bigger. Just in the last 30 years, they've gone from what now seem like almost like toy-sized turbines to things that are just truly massive. So the ones being installed in the UK and China right now, which have the largest systems, the turbines are something like 600 or 700 feet tall. So the size of a 60-plus story skyscraper. And each of the blades is a football field and a half. They're massive, massive structures. They say that a single spin of the turbine is enough to power a home for a day. So they're just enormous structures being built. This is what they look like, the ones being built in China right now. They have like a movable oil rig size structure that they position as they're building it, and then a special ship that they use to bring these turbine parts out there, and then they build it, and then they move that movable infrastructure to the next site to build the next turbine. It's just the scale of this is enormous, right? But this is, where things could potentially be heading. And this is, one of these farms actually off of the coast of the province in China as well, where they're building out these really large offshore wind facilities. So this is where things are heading. The potential is huge. And so the question is, well, like, is this a good thing for the ocean? How does it compare to other systems? And in more narrative than data-driven ways, I just want to tell the story of how I think about the comparison. So if you look at offshore wind versus oil and gas development, I just say, I don't want to think about it anymore. Off the table, it's just not a sustainable way to do it. We need to be moving away from fossil fuels for all sorts of reasons, whether on land or in the ocean. I think that's not the future. But what about other sustainable energy production systems? So we have onshore wind. So this is what these, and these tend to be smaller. The wind resources are smaller, which is why you don't need as large turbines. Plus, I think people would be a little wary of these giant skyscraper-sized turbines in their backyards. So they tend to be smaller and more concentrated. And they're good, but a big critique of wind farm, and if you've listened to my stupid president speak about wind turbines, they kill birds, they're terrible. Yes, they kill birds. And actually, on land, the wind turbines kill at least 3 to 4 times more birds than the ocean ones do. There's a lot more birds on land. They also kill more bats on land than they do in the ocean. So strictly on the wildlife comparison, offshore wind is actually much better than on land wind. They're also larger, so the birds can fly under them more easily if they're closer to the water and they're spaced further apart. So there's just a lot less mortality per turbine in the ocean. I'm sure all of you know that wind turbines are not the major cause of death for birds. House cats and windows do something like 1,000 times more deaths for birds than wind turbines. So if you're concerned about birds and bats, don't have cats. So either of these will be better for that. But if you're doing this comparison, the main issue for people raise about wind turbines is wildlife concerns and deaths to birds, and offshore wind turbines are much better. Solar is another big one. It's a great resource. When it's done at industrial scale, this is what it looks like. You convert whole landscapes into these fields of solar panels. It's less destructive than other kinds of land conversion, but it is a major conversion of that land. But it also takes a lot of water to produce solar panels. It's a huge water consumption. And offshore wind turbines have a much, much smaller water footprint for the production of the infrastructure. So again, if you're thinking about multiple types of environmental pressures associated with different energy production systems, offshore wind does better. A couple more to think about. Hydroelectric. It's a common one, been around for a long time. It's great in a lot of ways, but I think we all know it has a lot of impacts to the ecosystem. It floods the waters behind that, often displacing people and wildlife for sure. For that lovely salmon and other anadromous fish that use rivers and for passageway, it's had huge impacts on the population dynamics of those species. And so it's definitely got a larger biodiversity ecosystem impact than offshore wind does. Nuclear, there's been a resurgence of interest in nuclear energy for a lot of reasons. It's very, very sustainable in a lot of ways, but it too uses a ton of water in order to drive the turbines that are powered by the nuclear energy. And of course, there's the issue of the waste, the radioactive waste. What do you do with that? And it's one of the main reasons that nuclear energy was paused effectively for the last couple of decades is because people didn't want to have to deal with the nuclear waste being stored in their backyard. So where do you put all that? And then the last one is geothermal energy. It's very sustainable and there's massive potential. It doesn't have to be just in Iceland where you've got the volcanoes at the surface. You can use wells or bores that go deep into the earth where it's a couple miles down, it's hot, and you can drive turbines that way. But again, it takes quite a lot of water to do that. So all of these sustainable energy production systems are good in a lot of ways. But when you stack them up against offshore wind, there's a lot of things that make offshore wind a better option. And so in doing these comparisons, I come to the conclusion that, well, if we're really trying to produce a lot of energy and our economies and our societies are driven by energy right now, we need to doing that. Offshore wind energy is really a huge potential for doing that in a very, very sustainable way. But you can imagine a seascape that is just littered with turbines, and these places already exist and they're expanding. Where it's just I don't think people know really what the ecosystem scale consequences will be of thousands of square kilometers converted into wind farms where you've got the structure there, and there's a lot of noise pollution that comes from wind turbines that is destructive to especially marine mammals, that are effects that we don't fully understand. And so I get a little nervous about what a full-scale development of the ocean for offshore wind would do to the oceans and the biodiversity within it. Okay, chapter 3, the last one is minerals. This is a little bit shorter because this is really in the pilot phase, if you're aware of where things are at with deep sea mining. But there is a huge interest. Again, my government is currently pushing for this to happen quickly. There's a lot of international interest in this, and because there's just huge resources of really valuable minerals in the deep sea. So these have been mapped pretty well. This is what it looks like in terms of these resources that come as nodules, like potato or golf ball size, really, really rich metal balls on the seafloor, or these sulfides at the vents that accumulate around the hydrothermal vents, or you can get these crusts that form on and they're all mostly created by slow precipitation of these minerals and metals out of the seawater. So it can take really millions of years. The nodules, to make something that's the size of a potato, they estimate something like 10 million years to produce that nodule. So it's a really, really slow process, but it's really high concentration. So you can imagine, as a mining company, it's like walking up to a giant field of super concentrated gold just sitting there waiting to be taken. Like, it's a really, really amazing concentration of high quality, high density resource. And there's a lot of it. So these metals, the 4 that I'm going to talk about, are really, really valuable for 2 things in particular: steel, as key components of steel, and batteries. So a lot of these resources are critical to our current economies, both in terms of production of everything for steel and for sustainable energy through electric vehicles or other battery-powered structures that we need to build and support all these batteries. And these resources are critical for them. So cobalt, one of the key ones for both batteries and steel. There's something like 5 times as much cobalt in the deep sea as there is on land. So like a lot of it. Copper, we know what copper's for, electrical conduits. There's a lot on land, so it's not as critical to go to the deep sea for this, but there's still a lot of it down there. Nickel, again, for batteries, is really valuable. About half of all Earth's nickel is in the deep seas. But the big one is manganese. So if you're not familiar with manganese, it is the thing that makes stainless steel stainless. It makes steel much stronger as well as malleable. So it's like it is in along with iron, manganese is critical for steel. It's also valuable for batteries. Every single AA, AAA battery you have is mostly manganese dioxide. It's critical for lithium-ion batteries as well. So it's a really important way. It's the cathode for batteries. So it's what releases energy in battery systems. It's a kind of a magical thing too. It makes rubber stronger. It's actually long been known to help make glass clear. They call it glass makers call it the soap of glass making because it helps make glass clear. So it has tons of uses, historical and current. And as you can see, at least 50 times more manganese in the deep sea than is on land. And so it is just a profound resource that is critical to so many parts of our economy. And these manganese nodules, which are highly concentrated in many parts of the world, and in particular in the Clarion-Clipperton zone that was off in the middle of the Pacific, south of Hawaii, is where a lot of interest in deep sea mining has been focused. And this is what the mining companies would like you to think of this operation. This is their sci-fi version of this lovely little vacuum tractor going along and carefully picking up the manganese nodules off the seafloor and sending them up to the surface. What it really looks like is, so this is what a nodule field looks like. So in 1978, there was a pilot harvest done by a mining company. So the manganese nodules look like that. And then right after they sent the tractor through there, that's what it looked like. So you can see it's a huge conversion of that seafloor to basically heavily disturbed. And just last month, this paper was published showing they went back 44 years later to see what it looks like. And you can see that it's effectively the same. Which is not surprising, right? Because like I said earlier, it can take 10 million years for each nodule to form. So we're not going to expect anything to come back in 44 years. And we know very, very little about what lives in and uses the nodules. It's very deep. It's like 15 to 20,000 feet deep here. So it is a deep, deep sea environment. We know from other studies, there's all sorts of interesting and still unknown ecology that happens in the deep sea. It's a very sensitive system because it's mostly not light driven. And so what is in here, what uses the structure of the nodules, how does the disturbance of that affect biodiversity is very unknown. So it's hard to imagine that this is a good thing for those deep sea environments. We don't know how bad of a thing it is. But remember, mining on the land isn't particularly great either, right? It's a hugely disruptive system. So these are some of the manganese, cobalt, and copper mines around the world. Pit mines that, radically changed that spot. And then there's a lot of tailings and waste that are heavily toxic for the surrounding environment and get into our waterways and pollute them. So it's not like on-land mining is necessarily a great solution either. We need these resources if we're going to fuel our sustainable economy. Like we want to move to a green economy where batteries help drive a lot of it instead of fossil fuels. And a lot of these resources are critical for batteries, amongst other things. So this is the tension I'm feeling. Like each of these strategies, each of these ways of thinking about using the ocean have huge upsides, but also really potentially huge downsides. And there's a lot of risk to what that looks like. So what does that mean in my own thinking, and hopefully as we think moving forward about what we think about the kind of rush to the oceans for our sustainable solutions? And I want to rewind briefly to kind of further set the context of the way I'm looking forward. So that cumulative impact work that I showed you in the beginning, we have done some updates in the recent years to show how things are changing. So this work looked at 11 years of annual change from 2003 to 2013. And you can see that as we move forward over this time, it's getting redder and redder, which is not surprising. I think if you're paying attention to what's happening to the impacts in the oceans, we're getting more and more impact, even within just this 11-year period of how our cumulative effect is changing ocean ecosystems. We've just recently updated that. It's coming out next month with a current snapshot of what the world looks like in the 2020s, roughly 20 to 2025. And then what we've also done is forecast that into the future. So what it looks like around mid-century. And one of the sobering results from this work is that in the next 30 years, we anticipate more than doubling of our cumulative human impact on the oceans, just from the existing uses, not any of these future ones that we've been talking about. And the change is like basically everywhere that's yellow, orange, or red is going to get worse, which is the whole ocean, basically. And much of it is going to get much worse. So this, again, is kind of the backdrop to what all these new uses will expand into. And so, if we care about the ocean, if we want to think about sustainable solutions, not just for humanity, but for the oceans, we need to be thinking about this backdrop and how these new uses and expanding uses will layer on top of that. So I don't have any easy answers by any means, but the way I've started to think about it is I think we need to be embracing some of these new approaches and new uses of the ocean because they have so much potential for providing the resources we need in sustainable ways. But we need to do it in a way that I am kind of talking about as a planetary deal, where if we're going to expand into the ocean, we need to compensate for that at a minimum by reducing our footprint on land, but also maybe aggressive protection of equivalent or greater areas for the space that we use in the ocean. So we can't just add new use to the ocean, new impact to the ocean without an offset, effectively, a benefit to the planet in some way. And I'm not trivializing how hard it is to negotiate this politically or through economic markets. But I feel like if we can do that, then the expansion of the ocean is going to actually be a sustainable solution for our planet and for humanity, not just a further impact on the ocean. So with that framing, I do think that aquaculture in the ocean is a key part of that strategy. I'm not sure I want the China version of it, but I think we need to be moving more into the ocean to produce food, again, under this sort of planetary deal framework. I think offshore wind has huge potential and is something that we really need to be thinking and doing more of if we want to supply energy to our global economies. I am much more reserved about deep sea mining. I think there's still so much we don't know. The scale and the cost of doing that is huge. And we have lots of systems for managing what we do on land. It's highly imperfect. We know a lot, and I think energy put towards making that better and more sustainable. We're not in a shortage of those mineral resources on land. We're not at some peak where we're running out. We just need to be able to harvest those more sustainably. I'm less enthusiastic about moving into the ocean for mineral use. So that's where I'm at. It's an evolving process. I learn and think a lot about this. I think there's a lot of science to be done to further understand what these future uses of the oceans might look like. But I hope in walking through all this, I've at least made you think a little bit more about these issues and maybe even changed your mind a little bit. So thanks so much.
While you're all thinking of your brilliant questions, I just want to also acknowledge the SENV Scientific Foundation, so Ben's here because I nominated him in 2023 for the Australian Academy of Science SENV Fellowship, which basically means he gets to go around Australia and give presentations that meet Australian people, scientists. So that's what he's doing here. He's been to UWA, University of Sydney, and
here.
The best for last. SENV has been doing this since 1978-ish, I think. And they give one a year, sometimes two, and anyone in the world can apply. So super cool that Ben got it and that they're acknowledging the importance of conservation and ecology over probably a whole lot of applications in other fields. So, all right.
Yeah.
We'll take questions. and I'll just have a Zoom.
Yeah.
Thanks so much for your talk. Really interesting.
Thanks.
I had a question. I think, yeah, it covers most of it, but mainly about the food side of it.
Mm-hmm.
Obviously, it seems from your presentation that maybe agriculture and some particular food production is the way to go. And I was curious if you had done any work or thinking about doing any work on looking at scenarios of what that might look like. I can imagine, for instance, if we rapidly ramp up salmon agriculture, that's going to disproportionately areas of the outcome of that might be.
Yeah, we haven't modeled like specific locations per se, but we have looked at, so fed aquaculture, which salmon is an example. It's actually a small percentage of aquaculture, but it's the highest value stuff. And there are limitations to the feed components, like the forage fish. There's a limit to how many forage fish there are, and they're really necessary and valuable for fed aquaculture, and there are limits to what you can do that. So if you scale up aquaculture, you will effectively run out of the feed components. And so we've looked at different scenarios and solutions for how to compensate for that and what that means. We've looked at how climate change is shifting where different species can be grown and how that limits not just salmon and other fed species, but also shellfish that are sensitive to acidification and temperature. So we've looked at where you will lose potential areas as well as gain potential areas. So we've been looking at that kind of stuff, but we haven't said, okay, like what does the ocean look like if you turn all of Tasmania into one giant salmon farm or something like that? I think my sense is no one's actually advocating for that. And it's more what you end up getting is in particular locations, people are thinking about like marine spatial planning. How do you locate aquaculture facilities within the complex seascape of all the other uses, and how much do you allow versus other uses and so on? I think that's where more of the conversation and negotiation and policy is happening. Yeah.
Sorry, repeat the question.
Yeah, okay.
Just repeat the question. Says Zoom.
Yeah, right. Thanks. So the question was whether we looked at disease spillover from parasites and others in aquaculture systems. And in that cumulative environmental footprint of food production, no, we looked at those four pressures. We're well aware of the disease issue, but there aren't global data on that or sufficient data to really capture it in the same way that we could the other ones. So yes, it's definitely a concern, and certainly for example, salmon and sea lice, it's a major issue. There are disease issues with crops as well, obviously, as well as spillover genetic pollution, which is one of the other concerns of fish farming. Is you get hybridization or other kinds of things happening with escapes, when there are always escapes, and so those two issues are concerns for sure. I don't know how they would stack up, honestly, against other food production systems. So my whole thing is like, we have to move away from looking at one issue, one thing at a time, because you can always find something negative about food production because it will have an environmental impact. There's no way to have free food. You can't have a free lunch, right? So how do we compare across all food systems? And I think that disease and genetic pollution are a major concern across most food production systems. I just have no idea how aquaculture would stack up against these other ones. There aren't enough data yet to really address that. Yeah. 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 So the question was about chemical pollutants from antibiotics and other treatments for dealing with parasites and other diseases that happen in fish farming. And no, it's the same answer. Like there's not enough data to address that in the way that we did. We're well aware of it as an issue. And like any kind of farming system, there's huge variation in how it's done. So like a lot of the salmon farmers, like the companies, are moving away from the chemical toxic strategies for biological ones. So they have these lump sucker fish that are like predators to sea lice, and they actually farm and stock the pens with the lump suckers as a way of dealing with sea lice instead of using chemical pollutants or chemical treatments. But other places are still relying on them. And yeah, they definitely are a pollutant from that. We see that on land agriculture as well. There's tons of pesticides that are used that are really toxic for the environment. So again, we're aware of it as an issue. I encourage trying to think about it holistically rather than one sector or one issue at a time, because you can always find fault with something if you're looking at it alone. It's really a question is comparatively, what is the best way? I don't know the answer to that. Sure.
There was Tina, so the question is down here. Do you think there's a risk that we focus too much on making current systems more efficient and expanding them without addressing the root causes of them?
Yeah. So yeah, I mean, obviously the root problem of sustainability is that there's a lot of people on the planet, and those people are becoming wealthier, and wealthy people consume more. We are all probably at fault for that. Yeah, I mean, that's a sociological, economic, political question that's frankly beyond my pay grade to figure out how to do. But yeah, I mean, we need dual solutions. I mean, if we can figure out ways of reducing our consumption, that's a key part of it. It's really, really hard to do that. You know, there's just like human behavior has shown that it's really difficult to change that. And so if we can focus on ways of reducing the impact of the consumption we do and that more people are doing, I think that's probably the more direct way of solving the problem, even though it's not addressing the root cause of it. But yes.
One more question, and we can go downstairs and you can ask your questions there.
Sorry.
Great talk. I had a question about the energy side, but kind of like a lot of the opposition. I just drove through the area and had massive billboards with like a dead whale on the beach, like an AI generated whale, and, you know, being terrified in the background. And so a lot of the opposition is like serious, but genuinely did seem from the community was about the kind of conservation of biodiversity, despite the potential benefits.
Yeah.
And they have, you know, seasonal whale migrations in that area, so whales are very important. And so there's, because it's a very new industry, for example, they also have shipping containers that go past it.
Yeah.
So does it need kind of, is this a branding issue? Because it seems like we need to get cops a lot of this.
Yeah.
So it almost doesn't matter that there are all of these benefits in terms of other impacts in terms of energy generation, and it might impact less. If there's like a couple of unknowns, like the noise pollution,
Yeah.
it almost seems like that gets targeted. So yeah, especially like in a place like Australia or something where there's not much of this infrastructure. I mean, if there's, yeah.
Yeah. For those online, the question is kind of about the positives and negatives and political pushback against offshore wind in terms like of noise pollution in whales and other issues. And not a fair summary of what you just said, but anyway. So yeah, I mean, I would say there is genuine concern about the noise pollution from wind turbines, the construction of them, like any construction, but there are ways to do that that are timed to avoid whale migrations or sensitive locations and things like that. It's not perfect, but it's also, you know, brief brief moment in time when that construction is happening. So there's ways of trying to be careful about that. What is less known, I think, is so the turbines, when they spin, they vibrate. And that vibrational noise goes down the tower and into the water, and it actually can be quite loud, like louder than a jet engine with these really big turbines. And so when you have dozens or hundreds of these turbines all vibrating, that vibrational noise, we're still waiting to see what that means for whales or other, especially marine mammals that or anything that uses sound in the ocean to navigate or to feed or for other behavioral strategies. And so it's definitely a legitimate concern, but you brought up the great point. Like, we have a massive transportation system of huge ships that are making way more noise than that. So it feels a bit like a red herring argument against offshore wind to be like, oh, noise pollution. It's like, well, we've got a lot of other things that are making a lot of noise too. So are we willing to like stop global shipping? People seem fine with that, even though it's the same kind of issue. So I get a little concerned when people are arguing against something without, again, putting it in the bigger picture. Like, if we're worried about noise pollution, global shipping is actually the main problem, not offshore wind in terms of, or even like military activity that's doing all sorts of really high intensity sonar pulses and stuff like that. So again, if we're going to argue against things, let's put it in the broader picture. The other interesting one, and I'm now riffing and moving beyond your question, but a lot of people are against offshore wind because of the aesthetics of it. They're like NIMBYism. We don't want that in my backyard. It'll decrease my property values. I don't want to have to look at that. I get it on one level, but it's a really fascinating cultural thing. In Denmark, they've shown, economists have studied this, the property values are higher where they can see wind turbines because the people are excited to know that their energy is coming from a sustainable source, and they take in that, and having a property where they can see they're proud of adds more value to it. And so this value of the view of the wind turbines is absolutely a cultural thing and malleable. And so this is something that, with an effective campaign, creating a new narrative around what offshore wind turbines are, could radically change that really quickly. And so I'm less concerned about that one, although it's very real for how people feel about it.
Just getting messages that our pizzas are getting cold.
All right.
Please welcome or join me in.